At this point, it almost goes without saying that a lot of the work we've done so far in software-defined radio has involved either the decibel scale or some logarithm conversion. Normally, the purpose was to compare one power level to another. This is the case for comparing the power of a radio signal versus the power of the surrounding noise. This was also used with the filters and amplifiers, which could take in a signal and either increase or reduce its magnitude. In those cases, it involved the common logarithm, which uses 10 as the base. We also have the equally important natural logarithm, which uses Euler's number, or E, as the base. The two are common enough to show up on most calculators, computational software, and in a lot of software libraries. Slightly less common is the binary logarithm, which is the tool you would use, for example, if you want to know how many binary bits you need to have in order to store a positive integer. But what happens when you need a different base entirely, or even a fractional base? For that, algebra and the log quotient rule gives us a pretty good conversion for using pretty much any base that we want. All you have to do is take the logarithm of the antilog and divide that result by the logarithm of the base that you want to start using. You can use common logs, natural logs, or binary logs as long as you're consistent about using the same type. Because these can get a little bit repetitive if you're doing them over and over again, I'll be using the computational program Scilab to do this. For users of MATLAB and GNU Octave, the procedure for those tools is very similar, and I also have a separate write-up on using the same technique for GNU Octave. Today I'll be using Scilab version 6.1, and let's go back to that example of storing large integers as a set of binary bits. So if we want to store the number 2 million, pretty large number, we would use the number 2 million as the antilog, and we would use the built-in binary log function, log2, to calculate the number of bits needed to store it. After that, we use the ceiling function to round up away from 0, and if we wanted to make this a signed integer, we would add one additional bit on top of that so that that additional bit can work as the signed bit. Realistically, you would probably use 32 bits instead of 21 or 22 bits, but the basic idea stands. But what if we wanted a less common base, like 3 or 0.5 or something? For that, I'll create a function using the edit command. In the console, I'll enter edit arblog. Arblog is just the random name I picked for this function. And that will bring up Scilab's editor. Inside the parentheses, I'll include the two input values, so that's going to be base and antilog. And to keep this a little bit readable, I'll break this up into numerator and denominator terms. So I'll say the numerator is equal to log base 10 of the antilog. I'll follow that up by saying that the denominator is equal to the logarithm of the base that we want to start using. And finally, I'll just say that the result is equal to the numerator divided by the denominator. We put the result value inside the square brackets, and to put it to use, we select execute up at the top and hit save and execute. So now we're done editing the function. We can minimize that window, go back to the console, and test out our function. So we'll enter arblog parentheses 2, 2 million to repeat that earlier calculation. And it looks pretty consistent. As a sanity check, we can also take 2 raised to the latest answer and just back check that that value is consistent with our antilog. And it comes up as being exactly 2 million, so that would be exactly the same. We can also do the same thing with fractional bases and see that these yield negative results, and this is pretty useful, especially for bases that are larger than 0. If you like working with wireless signals or embedded systems like the Raspberry Pi, be sure to check out our blog, unboxingtomorrow.com, and for exclusive information, monthly polls, and lessons learned, also consider joining us on Patreon, and as always, have a great day.